So our first step here for our solutions lab is to weigh out exactly 12.48 grams of copper sulfate. So I'm going to click the little tare button to remove the mass of the beaker. I'm going to weigh out exactly 12.48 grams of copper sulfate pentahydrate. It's a blue powder. All right, so we got exactly 12.48 grams. Now we want to dissolve this copper sulfate in as little water as possible because we're going to need to get it into this volumetric flask. And to do so, the solid would get clogged in, so we have to dissolve it first. So we're going to add just a little bit of water, way less than 100 milliliters. So I want to be way below that 100 mil line. So I'm just going to add some water in, as little as possible just to start. This is a stir plate. It's a hot stir plate. I'm going to be using the stir function here. And then I have a little stir bar. It looks like a little pill, but it's magnetic. And then when I go ahead and turn on the stir function here, it'll actually begin to spin on its own. So it'll do the stirring for me. All right, so I just want to make sure I watch how much water I add, as little as I can to get this solid dissolved. And then once it's pretty dissolved, I want to go ahead and pour it through this flask, through the funnel into this flask. While this is going, this is a beaker, which we never use to measure things. It's not incredibly precise. So we wouldn't want to make a solution here if we can avoid it. Sometimes you can't, but a lot of the time you can. When we can, we want to use something called a volumetric flask. So these are incredibly precise. They're some of the most expensive glassware you'll ever use in this class. But there's a little line right here if I remove this funnel. And if you get exactly to this line, this is a 100 mil volumetric flask. So if you get exactly this line, you have exactly 100 milliliters. So the highest precision you can probably get in a regular chemistry class. So it's a pretty expensive piece of glassware for that reason. And we want to eventually make the solution in there. So I'm going to pause this, wait for it to dissolve, and then I'm going to be pouring it into that fancy flask. All right, at this point, it's pretty dissolved. Most of the solid is dissolved throughout the water. So I'm going to go ahead and stop stirring. I'm going to transfer it into this flask using a funnel so I just don't spill any. So this is a long stem funnel because a powder funnel is too wide in order to get into the flask. Okay, so we're going to go ahead and pour the liquid through the funnel. And you'll notice I'll still have some stuff inside my beaker, and I want to get that all out. So what I'm going to do, I'm going to go ahead and tilt my beaker. This is normally a two-person job, but Miss Hall is by herself. So I'm going to go ahead and I'm going to make this a little higher so you can see it. So I'm going to go ahead and tilt the beaker, and at the same time, rinse all of that water out with a wash bottle, making sure I don't get anywhere near that 100 mil line. Because the max I can get is up to here. So I want to make sure I stay away from that line as close as I can. Get all this solid out. Now, you'll probably have some of the solid stay in there. There's not too much you can do to avoid that apart from rinsing as much as you physically can. Some will probably get stuck in the funnel itself. There's only so much you can do as a high school scientist, so just do the best you can to get all of that solid out. There's always going to be some error, but just do the best you can. All right, so at this point, we've gotten all the solid out of this beaker, and it's into this flask. At this point now, we want to make our final solution. So we need to get the water up to this line right here, which might be a little faint. That's what we have to add water to. So I'm going to add some water into this beaker here and pour until I get close. You could also do this with the DI water here. Just depends on what your teacher instructs you to do. We're going to pour until we get close. And then once we get to the bottom of that little stem, I'm going to grab a pipette just so I can be really precise and go drop by drop up into the line. There's a little meniscus on there. It's like a curvy little part to it. I want the curvy part to be at the bottom of the line. Now, if you're impatient, you won't get it there, but if you are patient, you will. So I probably need about one more drop here. Okay. At this point, I want to dissolve all my solid. It's not completely all dissolved. So I put a little stopper in here. Other schools might have little caps that are yellow to put on them. I'm going to stopper the top or cap it and shake until all of that solid is dissolved in. So you have a homogeneous solution, meaning the solid is 100% distributed and dissolved in the water, and it's no longer any kind of solid at the bottom, which it looks like I have already achieved. So I'm done with that. This is my 0.5 molar solution. If you want to take a screenshot of that, you will need a picture of that for your data table. That's your 0.5 molar. This is your stock solution that we just made of the copper sulfate. Now we're going to do procedure 2, which is preparing a dilution. So right now we have 0.5 molar copper sulfate, and we want to make 0.1. So we want to reduce the concentration by 5. You should have done the math for this already, but you should determine that you need 10 milliliters of this stock solution. So what I'm going to do is I'm going to grab this stock solution. I'm going to grab 10 milliliters of it. And I'm going to put it into a 50 ml graduated cylinder because I want to make 50 milliliters total of solution. So I grabbed the 50 ml size. Technically, you could grab bigger as long as there's a 50 ml line and a 10 ml line on here to be able to see. But a lot of time it's easier just to grab the size that corresponds with the amount that you want to make, if it's available to you. So I added it up to the 10 milliliter mark. And I want to dilute this, so I want to fill it up to the 50 ml mark with water, which means if I currently have 10 milliliters in my stock, I want to add 40 milliliters of water because 10 plus 40 is 50. That will give me a total of 50. So I'm going to get some water. And I'm going to pour it up to the 50 ml line. Once I get close, I'm going to slow down. This can also be done in a volumetric flask, but a lot of the time, because dilutions require 2 liquid measurements, it's easier to do them in a graduated cylinder and it's more common. But you easily could have done this in a volumetric flask by measuring out in a graduated cylinder first, pouring it into a volumetric flask, and then adding a certain amount on top. So once I got close to that 50 ml mark, I'm now just going to go drop by drop till I get there. And you can do this with your wash bottle or with a beaker of water. Both will be fine. And there we go. So that is our 0.1. I'll go ahead and move the 0.5 out of the way. You'll need a screenshot of that for your data table. This is the 0.1 molar copper sulfate solution. My last step here is to use a colorimeter, which is what this is, attached to a LabQuest, which is just the computer that reads the reading. This will read the absorbance, which simply is how much light it absorbs at that specific wavelength. So we're going to be choosing a wavelength of 635 nanometers, which is corresponding near the red end of the spectrum because this is blue. So it emits kind of the opposite color, if that makes sense. But in simplicity, this will tell us how much color it absorbs. The higher the absorbance, the more concentrated it is, which should make sense. So this absorbance will allow us to calculate the actual molarity of the solutions that we did because they're colored. So my first step is I have this cuvette here. Ideally, you want to handle it on the top of the cuvette so you don't get any of your finger smudge marks on the side. There are clear sides of this cuvette, and then there's an opaque side, which is kind of ridged. We want to make sure we use the clear sides. So my first step, I selected 635, but just by using the side arrows here, I attach this to the LabQuest and turn the LabQuest on. Now I want to calibrate the colorimeter. I'm going to do this by using water as my control. So I'm just going to get some water here, add it into the cuvette till it's about 3/4 of the way full, so 75% full. Okay. I want to open up my colorimeter. Inside the colorimeter, there's a little white arrow. We want to line up the clear sides of the colorimeter, of the clear sides of the cuvette with that white arrow, little white caret. I'm going to close. It'll probably read an absorbance of 0 that's been calibrated before, but we're still going to hold this little calibration button to set this as the 0 absorbance. It's going to hold this down until it flashes. And now it is calibrated after it's done flashing, and it reads an absorbance of 0, which it was before anyway. But even if it was or wasn't, we still want to calibrate it when we use it. Now I'm going to just dump this water out. Okay. And then at this point, we want to measure the absorbances for my 0.5 and my 0.1 molar solutions. So I'm going to grab, this is my 0.5. Ideally, you would grab some of your solution and rinse out the cuvette first, just because there's probably some water in there. So if you don't rinse it out, you might have a lower molarity reading than what's actually true, or absorbance reading. So this just ensures that the whole cuvette is rinsed with what we want, not water. Now we're going to go ahead and grab that, fill this up 3/4 of the way with my 0.5 molar. I'm now going to go ahead and put that into the colorimeter and read the absorbance with the clear sides lined up. You'll notice now the number is going up. And we have an absorbance reading of 1.562. So you'll want to record that down for the 0.5 molar solution, or 1.56, yeah, 2, perfect. I'm going to go ahead and dump that out and do the same thing for the 0.1. Again, just to ensure, if you're not using a clean cuvette, rinse out that cuvette first with the solution you want, just to make sure it's all coated with the same thing. And then we're going to go ahead and add the 0.1 in. Make sure the clear sides line up. Go ahead and put it in the colorimeter. It should read a lower value, which we can see here, because it's absorbing less color, hence why it's lighter in color. And we get a reading of looks like it was stabilizing around 0.265. So that's what we're going to write down for 0.1. And that's it.